Welcome to the Deep Dive, where we cut through the noise of corporate headlines and really try to extract the core strategic insights you need to know.
And today, we're looking at what is, well, arguably the most radical and aggressive corporate transformation in recent memory.
Yeah.
We're diving into Project Titan. It's the story of Huawei, a company that was essentially cut off from vital global tech by U.S. sanctions.
Right.
And instead of collapsing, they basically embarked on this mission to rebuild their entire technology stack from the ground up.
That's really the mission right there, isn't it? Figuring out how a company facing an existential threat pivots, goes from being this global telecom giant to becoming a vertically integrated technology colossus centered entirely on AI and its own chips.
And the sources we looked at are clear. This external pressure didn't just, hurt them. It acted almost like a chemical catalyst.
Okay.
It forced this complete transformation toward building a parallel, self-reliant ecosystem.
It's fascinating just thinking about the scale of that. I mean, this isn't just a small pivot.
No, not at all. It's a multi-billion-dollar commitment to replace basically every crucial component.
Everything, like operating systems.
Operating systems, AI chips, even automotive solutions. They're essentially trying to build an entire digital world in parallel to the current global standard.
So how are we going to break this down today?
Well, I think we should look at it in three parts.
Okay.
First, that unique corporate culture and history. What made this kind of resilience even possible.
Right, the foundations.
Then, the money. The extraordinary financial commitment that's powering this whole self-sufficiency engine.
Makes sense.
And finally, the tech itself. The specific hardware and software gambits they're using to try and challenge global leaders. People like Nvidia, Google, but doing it architecturally.
Got it. So culture, finance, tech. Let's start with the culture. How does a company survive something like this?
Yeah, to really get it, you have to look at the history of the foundations. Huawei's corporate character, it's deeply rooted in the worldview of its founder, Ren Zhengfei.
His background is pretty relevant here, isn't it?
Absolutely. Born 1944, poor province, military engineering background. He founded Huawei quite late, relatively speaking, at 43.
Yeah.
And his experiences seem to have instilled this profound focus on survival.
And that led to this whole philosophy of eating bitterness, the Chicay idea.
Exactly. It's a cultural concept, really celebrates enduring hardship, collective struggle.
So when the sanctions hit,
It wasn't just corporate jargon anymore. The sources frame it as this genuine, non-quantifiable asset. It provided the cultural justification for extreme sacrifice. The long hours, the massive R&D spending demanded from everyone.
it sort of framed the crisis as a battle requiring total commitment.
Precisely.
Yeah.
And this capacity for collective struggle, it's almost like institutional memory for them.
How so?
Well, if you connect the dots, the sources detail this strikingly similar historical trauma back in 1990.
Oh, really?
Yeah, their PBX vendor supply was just terminated.
Yeah.
Abruptly. They had nothing left to sell. And that crisis forced them into in-house R&D, leading to their CNC08 switchboard by 93. It's like that early event built the specific survival muscle they're flexing again now.
So they're kind of explicitly built for endurance, prepared for a long fight.
I think so. And you even see that reflected in their governance, like the rotating chairman system.
Well, with Meng Wanzhou as one of the deputy chairs now.
Yeah, 3 deputy chairs rotating.
Yeah.
That system is specifically designed, apparently, to prevent leadership burnout and ensure stability. It signals they're optimized for the long haul, for a long war.
And that commitment to a long war, that must have translated immediately into some pretty tough financial decisions.
Oh, absolutely. A brutal, high-stakes financial strategy. They were clearly willing to sacrifice immediate profit for technological independence.
Okay, let's look at those numbers then. They tell quite a story, this V-shaped recovery. Revenue plummeted after 2020 from nearly 900 billion CNY.
A huge drop.
But then in 2024, it surged 22.4%, hitting 862 billion CNY, almost back to their all-time high.
It's an impressive revenue story, definitely. But you have to ask the critical question. How did they fund that pivot? Where did the money come from?
Right, because it wasn't free.
Not at all. It came directly at the expense of profit margins. Net profit declined substantially, dropped from 87 billion CNY in 2023 down to 62.6 billion in 2024.
So surging revenue, but shrinking profit. That sounds counterintuitive.
Well, it's not a sign of failure. It looks like a very conscious strategic trade-off. They're aggressively reinvesting basically every available yuan, every earning.
And that reinvestment is the engine of self-sufficiency you mentioned.
Exactly. They committed a staggering 179.7 billion CNY to R&D in 2024.
180 billion almost.
Yeah. And that consistently exceeds 20% of their annual revenue. I mean, 20.8% that year.
20%. Just to put that in perspective for listeners, that scale of reinvestment, it's purely optimized for long-term tech dominance, right? Not quarterly returns.
Absolutely not. It's structural self-reliance they're building.
And you can see where that investment's going if you track the diversification.
You can. The sources point out, okay, their legacy ICT business is stable, holding steady. But the consumer business rebounded massively, grew 38.3%.
And that's mostly the phones, right? The Mate 60, the Pure 70, with their own Kirin chips inside, driven by domestic demand.
Almost entirely domestic adoption, yeah. But the real star, the clearest validation of this whole vertical integration strategy,
is the automotive business, the IAS unit.
Yes, the intelligent automotive solution business. It surged an astonishing 474.4%.
Wow.
And crucially, it turned a profit for the first time in 2024.
So why is IAS the showcase then?
Because it's the live working example of their whole self-reliant ecosystem. You look at an EV running their solution.
Okay.
It's running on their proprietary Ascend AI chips. It's using the HarmonyOS cockpit for connectivity. It leverages Huawei Cloud for back-end services, and it even charges via their digital power infrastructure.
The whole stat, soup to nuts.
Exactly. It proves the entire stack works together coherently.
And this whole financial engine, this whole R&D effort, it's protected by what the sources are calling the Fortress China strategy.
That's a key part of it. Domestic revenue surged 30.5% in 2024. And now it accounts for, what, 71.4% of their total revenue?
Over 70%. That's huge.
It is. And that provides this massive protected scale. It's what's necessary to fund this unprecedented level of R&D and also to road test all this new proprietary tech before they even think about major global expansion.
Okay, so that sets the stage for the tech itself. The need for self-sufficiency forced this big hardware pivot.
Right. Cut off from TSMC, cut off from advanced U.S. tech. Their primary goal became creating their own proprietary foundation. That means Ascend NPUs for AI and Kunpeng CPUs for general-purpose computing.
But here's the big question. If they're constrained on manufacturing, specifically lacking the cutting-edge EUV lithography for, say, sub-7 nanometer chips, how do they even compete? How do they challenge Nvidia or AMD in high-performance computing, like in data centers?
Yeah, they can't win the raw chip power race right now. So that question leads us right to their core solution, the DaVinci architecture.
Okay, DaVinci.
This is their novel scalable AI computing core, and it's specifically designed to try and extract maximum efficiency from the less advanced fabrication processes they can access.
How does it do that? What's the structure?
It's highly modular, structured around 3 core functional units. Its main job is AI computation efficiency.
And those units are?
You've got the 3D cube engine. That handles the heavy lifting, the matrix multiplication, which is core to all modern deep learning.
Okay, the math engine.
Then there's a 2D vector unit for more flexible operations and a 1D scalar unit for control flow.
And the strategic advantage here is the scalability you mentioned.
Exactly. They can use a tiny version, DaVinci Tiny, maybe in a phone or an edge device, and then the massive DaVinci Max version in a data center accelerator. But the architecture, the code, it's the same.
Ah, so it's a develop once, deploy anywhere strategy.
That's the idea. Build the ecosystem internally.
That makes sense for their own ecosystem, sure. But what about raw performance? We know the current Ascend 910C chip uses SMIC 7mm, the N+2 process.
Right.
And that dual die design, which is kind of a manufacturing workaround itself, right? To improve yield and performance.
It is. But look at their public roadmap. It's aggressive, and it's clearly signaling long-term intent.
What are they projecting?
They're projecting the Ascend 950 series for late 2026, targeting 1 PFLOPS of FP8 performance.
Petaflops. That's serious compute power.
It is. And then the Ascend 970 in late 2028, targeting 4 PFLOPS.
Okay, PFLOPS, petascale floating point operations per second, just a measure of massive speed.
Right. By laying out this roadmap, they're essentially telling developers, telling customers, we're committed to reaching parity in the future.
Okay, the roadmap is one thing. But the real answer to the manufacturing bottleneck, it isn't just future chips, is it? It's this superpod strategy.
Exactly. This is where it gets clever. It's like asymmetric warfare.
How so?
Since they can't necessarily match Nvidia on the raw power of a single chip right now, they've shifted the entire battleground, from the individual chip to the large-scale cluster.
Okay, explain that.
The superpod architecture basically creates these massive logical servers. They do it by tightly integrating thousands of those Ascend NPUs.
And how do they link thousands of chips together effectively?
That relies on more proprietary tech, the Unified Bus Interconnect and the UB Mesh network topology. These aren't just jargon. They're the high-speed glue ensuring thousands of chips, perhaps made on slightly older processes, act together as one cohesive, massively powerful brain.
So we're talking about things like the planned Atlas 950 SuperPod, designed to integrate, over 8,000 Ascend 950 chips.
That's the kind of scale, yes. 8,192 Ascend 950 DT chips is the plan cited. The real innovation here is system integration, using architectural ingenuity to try and overcome limitations in raw semiconductor fab tech.
Clever. Using the system to beat the node.
You could put it that way. And that focus on the system level is vital, because even the best silicon is, well, pretty useless without a compelling software ecosystem around it.
Which brings us to HarmonyOS.
Exactly. It's evolved into this all-scenario operating system. The numbers are big, running on over 1 billion devices now, apparently supported by 7.2 million developers.
And HarmonyOS, combined with their Huawei mobile services, HMS, it acts like an ecosystem moat, doesn't it? Kind of replicating the Apple model.
That seems to be the goal. Lock users into a cohesive, interconnected experience across phones, watches, cars.
Yeah.
Make it seamless to stay within their world.
Okay, and on the AI development side, there's Mindspore, their open source challenger to, say, PyTorch or Nvidia's CUDA.
That's the parallel, yes.
So what's the key feature? What makes developers want to adopt this new stack, potentially moving away from established tools?
Well, Mindspore seems designed to simplify complexity, which is always crucial for adoption.
Oh.
It offers features like unified dynamic and static graphs. That lets developers switch between a flexible coding mode and a high-performance execution mode with minimal effort. Makes development easier, optimization simpler.
And how does it handle these massive models across thousands of Ascend chips in one of those superpods? That sounds incredibly complex to manage.
Well, that's where their vertical integration, that full stack control, really comes into play. Mindspore has native features for distributed training.
Okay.
But what allows for the deep cross-layer optimization is the whole stack working together.
Yeah.
You go from the proprietary hardware at the bottom,
Right, the Ascend chips.
up through CAN, that's the compute architecture for neural networks, basically the OS for the chips,
Got it.
and Mindspore, the framework. And finally, Model Arts, which is their application enablement platform, handles data, application delivery, that sort of thing.
So by controlling every single layer.
They can fine-tune performance in ways that more open, fragmented ecosystems might struggle to match. Deep optimization.
And this full stack approach, it's actually delivering results in the real world. You mentioned their ACT go-to-market pathway, assess, calibrate, transform.
Yeah, they're showing examples, like in manufacturing, the partnership with GIC Group, using AI toolchains built on the stack.
What was the goal there?
Pretty dramatic. Cut the vehicle development timeline in half, from 36 months down to just 18.
That's a tangible, high-impact result that really validates the integration effort.
It suggests it's working, yes.
Okay, so let's try and sum this up. Reflecting on this whole transformation, the strengths seem pretty extraordinary.
They are. The sheer size of that R&D commitment, for one. That incredibly resilient wolf culture we talked about, and their deep vertical integration, right from the DaVinci core architecture all the way up to the HarmonyOS ecosystem.
But the weaknesses are equally critical, right? They represent the potential ceiling here.
Definitely. The lack of cutting-edge EUV lithography for making truly sub-7-millimeter chips at scale, that remains the fundamental technological bottleneck.
Forcing them into these architectural workarounds like the SuperPod.
Exactly. And while Mindspore and HarmonyOS are growing fast, they still lack the global maturity, the sheer developer breadth of established ecosystems like CUDA or Android and iOS.
So what's the final assessment then? What does this journey tell us?
I think Huawei's journey offers this powerful, real-time case study in techno-nationalism.
Okay.
The company's successful, frankly aggressive pivot strongly suggests the potential emergence of a bifurcated global technology landscape.
Two parallel ecosystems.
Potentially. Two competing ecosystems, one centered on the established U.S.-led stack, and perhaps another centered on this Huawei or broader Chinese stack.
It really is an unprecedented situation unfolding. We've seen how Huawei's Superpod's strategy tries to bypass those fundamental manufacturing limits by innovating at the system level, integrating thousands of chips.
Hmm.
And this raises a really important question, I think, for the future of tech, something for you, the listener, to mull over. If architectural ingenuity and system integration can consistently compensate for or even outperform raw semiconductor power, does that decades-long race for the smallest nanometer process still hold the ultimate technological advantage?
That's the big question, isn't it? As the global tech landscape keeps shifting beneath our feet.